to the last section of binary compounds, naming formulas, and all that good stuff. This one, 7.4, totally different on the rest of them because we are finally moving away from binary compounds. To do this one successfully, you probably should have a lovely little worksheet that looks like this. Technically, this is something you don't need to turn in, but there are on the last page all those lovely problems that are the type of practice problems you need to be able to be comfortable with on the final exam and on the unit test. And so what you might want to do is just make sure that you have a copy for yourself. So yeah, I'll just continue with this, and then you can proceed through that worksheet. So forget everything you know about writing formulas and naming ionic compounds. Molecular compounds follow totally different rules. How do you know you're dealing with a molecular compound? You have two nonmetals. So we are finally dealing with those elements on the periodic table which are to the right of the zigzag line. Be careful, along the zigzag line you have these metalloids which sometimes behave like metals, sometimes behave like nonmetals, but generally in this course you're pretty comfortable with, you got two elements on the right hand side of that zigzag line, you're going to use the rules for covalent naming. So when you've all heard of carbon dioxide. The name itself tells you that you have one carbon atom to two oxygen atoms, and of course the formula with the subscripts shows you the same thing. Same with sulfur trioxide, nitrogen dinitrogen tetroxide or tetraoxide. You'll find in most convention that you drop the A here. The idea of having two vowels together is not popular. You will see, of course, some textbooks have both together. On the computer modules you'll find that I drop one of the vowels, but obviously on paper I would take either one. So what follows is one of those everything you ever wanted to know about stuff lectures but were afraid to ask. Make sure you got the handout and we will proceed. This is what you need to know about covalent compounds. Binary, make sure you realize that bi means two. For example, binary digits in computer technology. There's only two of them, 0 and 1. And amazing what computers can do with just those two digits. Binary fission in biology involves reproduction by splitting into two parts. By the way, in this course as well, binary fission, well, not so much binary, is going to involve the splitting of nuclear material. A binary covalent compound contains two nonmetal elements joined together by one or more covalent bonds. So get the idea of ionic bonds, of actually transferring electrons out of your brain. Atoms in covalent compounds do not connect by forming ions. Instead, they combine chemically by sharing electrons in a covalent bond. A binary covalent compound can have many atoms, such as this puppy, C25H52, a main component of candle wax. Or it could be simply a diatomic molecule having only two atoms, as in chlorine monofluoride. Prefixes indicate the number of atoms of each element that appear in the formula of binary covalent compounds. You're going to have to know these prefixes, and there's no better thing to do than to memorize them. And there they are. Mono, 1, di, 2, tri, 3, tetra, 4, penta, 5, hexa, 6, hepta, 7, octa, 8. This is for you piano players, or octopuses, octopi, 8 legs, an octave, 8. Oh, a better one is in this chapter even, the octet rule, where elements are trying to have 8 electrons in their outer shell to be like the noble gases. How about nona, 9, and deca, 10? I would recommend a little learning procedure here. I would grab a piece of scrap paper and I would number from 1 to 10, and then I would take that little scrap of paper, take it into the kitchen, give your mom a hug, and then show her that you can give the prefixes for 1 to 10. Fun. Right, your mom will appreciate that. So these are the steps in writing the names of binary covalent compounds. let's start with CO. The idea is to name the element on the left first. So the first element when we look at CO is carbon. Name the second element, making sure the element name ends with the suffix "-ide". So the second element is oxygen. Change the ending to "-ide". Now it gets interesting. Add a prefix to each element's name to indicate the number of atoms of each element in the compound. Exceptions to Rule 3: if the first element has only one atom, do not add a prefix. So in this case, we only have one atom of carbon. We're not going to add a prefix. The other exception would be the prefix mono is shortened to mon if it is placed before oxide. Yeah, you're not going to have two O's together. So in this case, do not use a prefix when there's only one atom. The compound's name is carbon monoxide. So let's do another one. We have 2 nitrogens, 3 oxygens. The first element is nitrogen. The second element is oxygen. Change the ending on the word oxygen to "-ide". And again, this time, you're going to have prefixes for both the nitrogen and the oxygen. And as your mother knows and you know, nitrogen is 2, oxygen is 3, a di and a tri. We're going to get dinitrogen trioxide. Sweet. So, on your little handout, you have the wonderful experience of writing the names of the following compounds. You could do this in your head because it's not terribly difficult. I'll give you, for instance, a dinitrogen monoxide, carbon dioxide, phosphorus triiodide, phosphorus pentachloride, sulfur dioxide. You get the point. Once you've done the naming, then you can write formulas. So in this little box, you're given the name nitrogen tribromide, capital N, nitrogen, Br3. Sulfur hexafluoride, hexa is 6, so it's capital S for sulfur, fluorine, capital F, and a subscript of 6. Again, what I suggest you do is you try those on your own and then stop the video and come back to it to check your answers. There you go. And hopefully you don't have any strange revelations or discoveries here. You got them all right, and you have mastered naming and writing formulas for covalent compounds. This is simply a summary for writing names and formulas of covalent compounds. I've also mentioned 3 formulas at the bottom of the page that don't really follow the rules, so you should just simply memorize the formula for methane, CH4, ammonia. This is not the ion ammonium. This is an actual molecule of ammonia. And then, of course, water, H2O, which is, if you like, dihydrogen oxide. We're done.